Hi Kerr, and thanks for the question. I saw that some other folks had commented before me, but I wanted to clarify a few things about the solution to the problem you posted. The thing that makes this problem interesting is that, just as someone suggested, our first instinct is to use L'Hopital's rule and be done. But in this case, your problem says that we can't do that, so we need to find another way. Let's start by rewriting the tangent of 4x as terms of sine and cosine. So that's going to give us the limit as x approaches 0 of 2 sine of 2x over the cosine of 3x times the sine of 4x over the cosine of 4x. Simplifying this into one fraction is going to give us the limit as x approaches 0 of 2 times the cosine of 4x, and I got that from the denominator, times the sine of 2x all over the cosine of 3x times the sine of 4x. At this point, I'm going to use one of the limit laws that says the limit of a product is the same as the product of the limits. i.e., I'm going to separate what I know from what I don't. And doing that, what you'll have is 2 times the limit as x approaches 0 of the cosine of 4x over the cosine of 3x times, now here's your new limit, as x approaches 0 of the sine of 2x over the sine of 4x. And you can see the reason I'm doing this is that I know the limit as x approaches 0 of cosine of 4x over the cosine of 3x, because plugging in 0 for x, you get cosine of 4 times 0, which is cosine of 0, which is 1. And then you have cosine of 3 times 0, which is cosine of 0, which is also 1. So your limit there is 1 over 1, which is going to equal 1. But we still have this pesky limit as x approaches 0 of the sine of 2x over the sine of 4x. And this is where we're going to need to use our fact of the limit as x approaches 0 of sine x over x equals 1. But right now it's not in that right form, so we can't just go plug it in and say, okay, everything's 1. So what can we do? Well, let's rewrite it in a certain way. So doing that, have 2 times the limit as x approaches 0 of sine of 2x over something, I'm going to leave that blank for now, times something, again leaving it blank, over the sine of 4x. Now what would be great? What would be great is if I had a 4x right here. Because if I did that, the limit would be 1 because of our identity over here, and we'd be great. So let's do it. But what's the consequence of that? If you multiply by 4x, you got to divide by 4x somewhere. So divide by 4 here. But since I'm going to do the same thing in the denominator of sine of 2x, I'm going to put the x over here. So see, I've changed nothing. Multiplied by 4x, divided by 4, divided by x. Everything's the same. Using that same thought, it'd be great if I had a 2x in the denominator here. Well, let's do it again. So I divided by 2. Let's multiply by 2. Just like that. At this point, we can solve our problem, because by our identity, sine of 2x over 2x as the limit of x approaches 0 is going to be 1. And so is this, because it's 4x over sine of 4x is also equal to 1. So what's that give us? That gives us 2 times 1 times 1 times 2 over 4, which ends up giving us the limit of your problem is equal to 1. Thanks for the question. I can't wait to see the next one.